And we're on. Good afternoon, everyone. Stephen Quigg, Principal Security Solutions Architect at AWS. This is a session on getting started with AWS Security. So it should be a gentle walk through the main security features of the platform and how you can safely and securely move to the cloud. I have the cold today. If I sneeze a little bit or I blow my nose, please excuse me in advance. Security is difficult. Enterprise security especially so. Before joining AWS, I was a security practitioner all of my career, and this certainly resonates with me. It was difficult to understand what we had and what was going on, and there was very little automation. We designed things, we procured them and implemented them, and then we relied on humans to manage and change things. Moving fast and staying secure were two competing objectives. If we look now, it's 2017. Most companies have an innovation strategy. We live in a very fast-moving world. Every business wants to move ever faster. And the challenge then that we face is, how do we move fast but stay secure at the same time? How do we take security from being a blocker to being an enabler in our business where it's built into the core of everything? Because choosing security should not mean giving up on the convenience. We shouldn't have to weaken the security to make it easier for us to do things. We should be able to move fast and be secure at the same time. We've got a prescriptive approach to security with AWS, and this is what I'll walk through today. Understanding how we practice security internally is very important as you do your due diligence over your cloud provider, that you understand how they do things. The compliance foundations that you can build on to meet your own compliance and security objectives. The integrated identity and access management features our platform has, and then the detective controls that we offer, how you can establish network security, implement data protection, optimize change management and your other ITIL style processes, and then finally start to automate the function of security itself. So let's start by understanding how AWS practices security. Security is job zero. Everything starts with security in Amazon, and especially in AWS. If any of you here have written a security policy or know your own corporate security policy, there'll typically be a line in there that says something like, don't run untrusted code. And it meant don't download things from the internet and run them on your servers. You don't know their provenance. Well, we built some data centers, installed computers in there, and said to the world, come and run your untrusted code. So it's crucially important that we protect every single one of our customers from every single one of our other customers. This is the entire point of a multi-tenanted cloud platform. So every single thing that we do starts and ends with security. We've made it part of our culture. There's a great phrase internally: if you're not sure you're having a security incident, then you are. Please raise a high severity ticket to the AWS security team, because there are people whose day job is to look at things and understand if something is bad or not. You don't have to make that decision. We have others, and everyone is then encouraged to constantly speak up about security. You'll never get in trouble for bothering the security team. We have a Chief Information Security Officer, and he has a team of engineers and incident responders and others, but we distribute the process of security everywhere. Everyone carries the responsibility. If you're an AWS service team, you're responsible for the security of your service. AWS Security give you requirements. They keep an eye on things. They audit and monitor things. But it builds on the established culture of ownership that we have, that everyone realizes, I need to deal with this. I can't have slopey shoulders and pass it off to someone else. I own this security problem until I've passed ownership to someone who can manage it on my behalf. And it also means then that our security team doesn't act as a blocker in the middle of our process to innovate. It means they sit alongside it, that the teams building these new services have security embedded in them, which means they don't have to go and seek approval. They can do the right thing. They can go and ask for advice on how to do things, for example, but we don't then have a gate where AWS Security has to sit in the middle and everyone has to pass through that gate, which is traditionally what happened, because when you do that, people flow around the obstruction in the river and just try and get their job done. And it was very important for us that we created an environment where everyone cared about security, everyone thought about security, and did the right thing without us needing these hard gates in the middle of it. Very, very few people have access to the cloud platform itself, which is the thing that you use as a customer, the underlying technology. We want that to be zero. Unfortunately, we're still not quite there yet, but we automate absolutely everything. We have a very, very small team of people managing what is a very large environment now, because if you ever need to do something twice, it shouldn't be done except by code. We have data center DevOps engineers whose job it is to look at traditional data center functions, for example, and figure out how we can automate them. Because if we can automate things, we can ensure they're high quality, we can do repeatable things, we can remove human error from the equation. And we're constantly trying to drive that human access down to near zero, because that offers a safer cloud platform for our customers to build on. Increasingly, customers tell us that moving to AWS is helping them with security. And if I think when I started out 5 years ago, and the conversation was very much about how can I trust my cloud provider, and that's still a very valid conversation, nowadays we see customers say, how can I make use of this to make my own job easier? How can I actually get rid of some of those security problems that I had on premise when I move to AWS and make my organization stronger? By moving to AWS, you gain access to the same services that are used by the world's leading banks and the world's leading startups. When one customer asks us to implement new audit controls, for example, that appear in our SOC reports, and we decide that that's a good idea, every other customer immediately gets the benefit of that. When you create an AWS account and start your first server in our free tier, you're getting exactly the same thing from us as Capital One or Netflix gets. So when the banks and others push us to offer more security functions, and the Netflix and the startups push us to move faster, and we decide to do all of those things, every single customer gets the benefit of it, which I think is really exciting. We have our own security teams who are working 24/7 on your behalf to build and run and secure that platform. And lots of people want to come and work at AWS because it's a challenging environment for them, so we attract really good talent. They are at your back as well. When we produce new security innovation and features, all of our customers get access to those features right away. You don't have to come and buy anything else. You don't have to sign any more contracts or go through a procurement process. When we release features and you're a customer, you can just start using them. And it is worth pointing out, and it's said before today, about 95% of the releases that we do, and we're on track to probably release about 1,200 features this year, 95% odd are driven by what customers are asking us. Customers get a good idea. We think the benefit would be to many customers, so we decide to do it. And then you also sit on top of the 30-odd global compliance certifications that we have. So if you have your own rigorous compliance requirements like PCI or ISO 27000, or you have to build applications for American healthcare markets, then we offer a platform that helps you do that, that takes much of the heavy lifting off you, like building and running data centers, for example, which can make things simpler and faster for your own business. So let's look at those compliance foundations. Every 6 months, we produce a SOC 1 Type 2 audit report. It's done by Ernst & Young at the moment. Every 6 months, we do a SOC 2 Type 2 audit report, also by EY, that lets you look at all the key controls in our environment, how they were tested, and the result. If we're having control failures in our Sao Paulo region, as a customer in the UK, you would know, because these are globally scoped audit providers, audits. We cannot hide these things for you because it happened to another customer. Every customer gets to see the same thing. We're PCI Level 1 certified for credit cards. We're ISO 27001 certified, quite obviously, for our information security management system, but we also have ISO 9001 for quality. If you're in life sciences or pharmaceuticals, that's quite important. We show alignment with UK government standards. You can connect to the UK PSN from our network now as well. For example, if you're building healthcare apps for the US, we offer HIPAA compliant services as well, for example, that you can build on. And as we grow and expand and our customers ask us for more, we look at more and more standards from different countries and we incorporate them into our control environment. We're now managing around 3,500 external security requirements that we must demonstrate our ongoing compliance with, so that you as a customer can take those audit reports, read them on an ongoing basis and do your due diligence that us as a service provider is doing the right thing by you. We're responsible for the security of the cloud platform itself. You as a customer retain control of the content and the solutions and applications you build upon us. And this is where shared responsibility doesn't mean, well, that's your responsibility. From our point of view, it means you're in control. You're using the same platform as a bank or a startup, but you'll have your own security policy. You understand the importance of your content to your business, so we give you the freedom to choose how to do that. You can use the tools that we provide, like our virtualized infrastructure, which includes things like firewalls, it includes lots of encryption technology, or you can just bring all your own security solutions on top of that as well. So you get to decide what level of security ultimately you have, not AWS. It means you remain responsible for your security in the cloud platform itself. Looking through some of those key features now, AWS includes an identity and access management service called IAM, simply, that offers really fine-grained access control to everything that you do. It means that you can take an AWS account, you can segregate the duties internally in there, so you can have people who look after security, people who look after infrastructure and compute, people who look after your storage and databases, for example, and implement those strong guardrails between teams, just like you would have always done on-premise. You can federate our identity service with your own on-premise services, like Active Directory, for example. So you have your own single sign-on portals that are on-premise that offer access to the AWS console, so you don't have to go and create new pools of users on AWS. You create roles, and then you do everything through role-based access, which, as most people know, is much safer, because then you can use the particular role for a particular job and just make sure that people just have enough permissions to do their job at any point in time. We have really straightforward policies that you write to control that access, that you can audit and monitor on an ongoing basis as well. Now, identity and access management controls who can do what. It's really important then that you understand who is doing what. AWS CloudTrail is a service that gives you a near real-time log of the activity on the Amazon APIs. And by that, I mean, when you want to do anything with AWS, you're calling an API, start a computer, change a firewall, create some storage, delete some storage. All of those actions generate logs in AWS CloudTrail that you can see. They're in a very simple to read format. They will go straight into tools that you're familiar with, like ArcSight and Splunk and QRadar and all the other leading SIEM environments. We have many partners out here today who also support this. You can enable cryptographic verification on those log files so that you can verify that no one started a server in an AWS region that you don't have an interest in, for example, that no one in your organization can do anything under the radar, that you can create write-only log files that are under the control of your security department. And then AWS CloudWatch is a service that monitors activity on the cloud platform. Tell me the CPU and network utilization of servers and give me an alarm when that CPU increases above a preset amount. You can feed that with your own logs. You can feed it with CloudTrail logs. And then you can create alarms when activity happens in those logs that you don't want. Take the really simple example of a fleet of web servers where one server generating a 404 might not cause you much of a panic. 100 servers generating 404s at the same time might tell you there's an immediate problem in your website. CloudWatch can help you do all of those things. And when it creates an alarm, you can send someone a text message, you can send it an email, but even better, you can trigger automation. You could have it raise a ticket on your on-premise ticketing system or your own service management system, for example. You could use it to run some code. We have a service called Lambda, serverless compute. You give it code and tell it to run it. When someone does a certain activity that you don't like in CloudTrail, you could run some code that went and reversed it, for example, and build all of this automation up yourself. So suddenly, rather than relying on humans having to read logs and make sense of them, we can start to configure the system itself to start understanding those logs and telling the humans when something bad happens that might want their intervention. Really, really simple, really, really powerful, really low cost. And with CloudWatch logs, you can feed it all of your own log files. So it's not just the AWS logs, so you can run the AWS agent on your Windows server, on your Linux server, and just feed it any log files that you want, and then you can start to look for patterns of activity within those logs. It's really important that you understand where your stuff is. When you use AWS services compute and storage, you must tell us where you want that compute and storage to be. That can be here in London, in Dublin, and Frankfurt currently. It will be in Paris or Stockholm soon in the EU as well, for example. So we have regions all around the world. So if you've got particular data privacy requirements, for example, you can choose to locate that data where it needs to be. For performance requirements, you can locate it close to your customers. You can use one region, you can use all of the regions. And when you use that AWS region, we will not move your content. Again, privacy is obviously very important in Europe. We have this thing happening called Brexit as well, so we have regions that are strategically placed that you can choose to use. In Germany, for example, there's some healthcare regulations that seems to encourage data to be stored in Germany. It's certainly the same in the UK. We have our Dublin region as well, which is quite an old and very large region now as well, that offers you the ability to do things and serve multiple countries within the context of GDPR. From a privacy point of view, you will always be in control of privacy. It's important that we work in such a way that supports your objectives. We've already announced that by the time GDPR is implemented, all of our services will be compliant. You can get the data processing addendum from AWS, that's the legal obligation between us and you as a data processor, for example. But you control what data comes to our platform. You control the format of it. You control whether it will be encrypted. You control who can see it, and you control how long it lives for. So the entire data lifecycle is something that you choose, not AWS. Our services don't know what you're doing. You don't have to tell us. If you've uploaded personal data, that's your understanding. We just see customer content. We treat all of our content with exactly the same level of importance, which is the top level of importance. It makes it easy for you then to classify your information, understand where it is, and understand how it's being used and accessed on the platform as well, so that you can meet your own privacy obligations. When you want to launch your first computers on the Amazon EC2 service, you have to create a virtual private cloud. So this is a construct within the AWS region. In the AWS region, think of a region as being a metropolitan area with many data centers in it. And we divide those data centers into what we call availability zones. Availability zones are in separate floodplains, they have separate power, they have separate communications and transit to the internet, for example, as well. Your virtual private cloud spans all of that. You take your VPC's address space, it's a private address space, it's also IPv6, if anyone understands that, and I'll put my hand up and say I'm no IPv6 expert at this point in time. But it allows you to take that network, divide it into small subnets, and then start placing your computers much like you would do today. So you can start to build architectures that have DMZs, web, app, database, and keep them all nicely segregated, exactly the same way that you would build on-premise if you were doing this. You can easily create many virtual private clouds. We don't really have any limitations on how many you can create. You can link them together privately using peering. You can link those virtual private clouds back to your own data centers as well and start to build your own hybrid environments. When you start a EC2 server, you must specify security groups for those servers. These are stateful firewalls that we provide that are all done in software. We implement much of this in the hypervisor and as compute services. We don't have any reliance on the network itself. It means we can operate a very, very simple and scalable network because all the intelligence we've built in software that doesn't rely on the capability of the network. So every single thing that you do happens within a stateful firewall. Those firewalls are completely closed by default. You must then open them using traditional looking firewall rules, allow this computer to talk to that computer on these ports, allow this group of computers to talk to this group of computers on these specified ports, for example. Really, really simple. You never run out of firewall ports. And as someone who was engineering things on premise for many years, we typically hit limitations on how much we could afford and other things. As we did our segregation, you will never run out of that segregation on AWS. Everything is private by default. When you create a virtual private cloud, it has no external routing. You must positively connect it to the internet. You must positively connect it to your on-premise network and then decide on which subnets can communicate where. So you're in full control of what can go where. There is no excuse, for example, to be accidentally connected to the internet, which is many customers fear. I create these things on Amazon, I link it back to my corporate network. Without me knowing it, someone will create a route to the internet that I don't know about. It's very, very difficult to do that. We provide tools that I'll talk about shortly that help you detect and monitor for things like that happening as well. The virtual private cloud gives you logs. We call them flow logs. If you're familiar with NetFlow, think of it kind of like a cloud version. This computer talked to that this IP talked to that IP, source port, destination port, was it an accept or deny? We deliver these logs straight into the CloudWatch service I talked about earlier so that you can immediately start to build alarms, for example. So if you've got a well-defined corporate network address range, you could build alarms that tell you if an address pops up that isn't part of your corporate network address range that might help you understand someone's made a configuration error. You know, and let's be clear, most bad things that happen are because someone screwed something up. They're not because of an attacker. But really, really simple to use logs that you can start to feed into a machine learning model. The previous session was about Amazon AI services, for example. I'm currently building a model that I'm training to say this is normal network activity. And then I want the model to tell me, well, this is definitely abnormal then. It's a very, very different proposition from the old days of installing things like an inline intrusion detection system and trying to rely on it telling us something bad was happening. Now that everything's HTTPS everywhere, it's very difficult to glean intelligence from the network itself, but there's a lot of power from the source and destination of events and how things communicate and talk. The AWS Web Application Firewall service helps you protect your HTTP-based applications from attack. You can enable this in different ways. We have a content delivery network we call CloudFront. You can simply turn the web application firewall on there. If you don't want to use our CDN, maybe you don't use one, maybe you have your own, maybe you have another CDN, then you can enable the web application firewall within the load balancers we provide. So within your VPC, you can have multiple web application firewalls sitting there looking for things like cross-site scripting attacks, SQL injection attacks, and other things. Everything that we do has an API, so you can quickly update your web application firewall in response to changing threats. Customers build automation that say, if my website has been scraped, for example, then automatically update my web application firewall to drop all the traffic from the bot that's doing the scraping. Really, really simple. No need to call anyone. No need to do anything except run some automation. DDoS is a continuing threat, I think, to everyone that's on the internet. Over the last year, there's been some terrifyingly sized attacks out there. Well, we have a service that helps you keep going through the largest of those attacks. Everything that you do on Amazon comes with some level of DDoS protection, because it's really important that we protect our customers from any other customer on that infrastructure, and that no customer undergoing a volumetric attack is going to affect you. We now offer a more advanced service called Shield Advanced that gives you access to human 24/7 DDoS response teams. They will manage your web application firewall on your behalf. They will keep your customer traffic flowing while you face hundreds of gigabits a second of attack traffic, for example, as well. It's $3,000 per month, which is insanely cheap compared to some of the things I used to see out there in the marketplace. And it gives you access to the technology and the people who are managing DDoS attacks on the Amazon.com infrastructure itself. And as you can imagine, Amazon is subject to large and ongoing DDoS that people just don't notice because so much work is happening behind the scenes. Once you've got your content on AWS, we have a number of ways that help you protect it. Chief one is cryptography, and then we've got a number of ways that you can implement your cryptography on AWS. We released the Amazon Key Management Service a few years ago. It's undergoing its FIPS evaluation at the moment. This is a really, really simple key management service that for each customer, we have unique customer master keys that are generated, or you can even import your own. And they're used to protect a number of data keys that are generated that can be used to encrypt databases, to encrypt your S3 storage objects, to encrypt the disks of your EC2 instances, for example. So you can then implement blanket policies like we will encrypt every single bit of data we upload to the cloud, which is quite a common policy from our customers. So we've made it as easy as possible. If you want access to the raw cryptographic hardware itself, we have the Amazon Cloud HSM service. So these are bespoke HSMs that are single-tenanted, which means you're the only customer of your piece of that HSM where all the cryptography happens. It offers an industry-standard interface. You can integrate it right within your own apps so that you can offload encryption to it. You can create large clusters of these things and load balance against them. You can take the keys from them and extract them back to your own on-premise HSMs, for example, as well. If you ever need to walk away from Amazon, you'll always have your keys with you. So again, you don't have that feeling that I'm locked in here because my data's encrypted, for example. The Cloud HSM service is FIPS 142 level 3 validated devices. You can check all this out on the FIPS website. You don't have to take our word for it as well, for example. But you've got an Amazon cryptography team working behind the background here who's looking at all the upcoming developments in cryptography and making sure that we stay ahead of the curve so that when you're using our cryptographic services, you're always going to be on the leading edge. And cryptography changes, you know, and it sometimes changes very, very quickly indeed. This gives you access to a team of people who specialize in that. There is a huge move to enabling HTTPS everywhere on the web nowadays. We make that simple for you now as well. The Amazon Certificate Manager is a free-to-use service that generates SSL certificates for you that you can then use in your Amazon load balancers and CloudFront, so you can easily make your websites secure. We will handle things like auto update of certificates when they expire. You know, there's so many problems caused by people forget to update and renew certificates. You can easily just turn these things on, for example, by us as well, and distribute SSL certs where they're needed. Really, really simple to use. Amazon Macle is a service that we launched in August, which uses advanced machine learning techniques to identify your classified information and help you keep track of it. Think of it as DLP in the context of the cloud. It currently looks at your S3 buckets. In time, this will grow out to uncover the other storage mechanisms that we know. But you can just simply turn Macle on. It will start to look at your S3 objects. It'll look for PII. It'll look for healthcare information. It'll look for source code. It'll look for things that look like corporate, important, confidential documents, and then give you a dashboard showing what level of risk it thinks you're exposed to. How are these documents being accessed? Did access to these documents suddenly change? So for example, did someone misconfigure a storage object and make it available more widely than it used to be? Macle will help you find that and react to that. It'll give you a workflow around DLP to start looking at. You cannot just use regex to find things like PII, hence it uses machine learning to analyze that information, compare it against the model it has to then try and classify that information automatically, for example. Really, really powerful. And just like we've changed the notion of what intrusion detection means because we have all these sources of information, so we start to change the notion of what data loss prevention means as well. Macle's currently available in US East 1 and US West 1. It's going to be rolled out in Europe very soon as well, hopefully by the end of the year, and all our customers can start to use it over this side of the pond as well. Change management is really important. Applications break because someone changed something and forgot to tell everyone. Security incidents happen because someone made a change and not everyone was aware of it or the change went wrong. So we've got a couple of things that really help enable our customers get better at the process of change management. The main one is config. We talked about CloudTrail earlier. CloudTrail tells you that I just called an API to do something. Config tells you what changed. Squig called the VPC API and said, change this firewall. A firewall change happened. CloudTrail doesn't tell you any more than that. Config tells you, Squig just called the VPC API and changed the security group to open port 25, which is quite a big security change because it may open up an email service. It may be an attacker trying to find an easy way to exfiltrate information, for example. And then it shows you those changes on a timeline. So that at the end of the year, you may be demonstrating to your own compliance team, to your own auditor, that this was a well-managed environment, that everything had a change ticket and we considered them. You can see all your changes over time. When you're trying to figure out why an incident just happened or your application just broke, config will help show all the changes that may have contributed to your current state. We built a bit of innovation on top of config and called it config rules. Now when a change happens, you can assess it against a security policy. A very common one, Amazon S3 is our online storage service. All of your storage buckets where you put things are private by default. There are many valid use cases for making those storage buckets public. It may contain your static website content, for example. But you might want to know when a bucket that was private goes public. Config will tell you. So when someone makes a change to the configuration of S3 and makes a closed bucket public, config in near real time will tell you that just happened. And as before, that could trigger a message to someone. It could trigger a piece of code to go and say, undo that change. Because that change, when it happens, is a critical change that my business never wants to see. I want my VPC never to be connected to the internet. Config will tell you if someone manages to evade the controls that you've put around identity and access management to allow them to do so, for example. So suddenly, your policy has been automatically monitored. And you see where we're going with this. We set things up securely, and then we use automation to help us understand that we're still compliant with the policy that we thought we had so that we can act quicker. And your first stage on that may just get a human to respond. But when you're at maturity level 2, it might be use some code to respond and tell a human at the same time. And suddenly we're managing incidents much, much, much faster than we ever were before. This is where you can start to really change how your organization thinks about security. Remember when reports were done manually, I had to do some of these reports. I would sit and clobber my way through Excel, and I would manually inspect systems and pull data back for them and hope to God my report was right. Now we can start to automate that. Everything produces data. We know the quality of the data is high, so let's use it automatically. We have a simple tool called Trusted Advisor that you can access if you're on an enhanced levels of support that tells you key features about your account. Am I performing well? Am I spending too much money? Have I got some inappropriate security settings, for example? So you can generate easy alerts that give you dashboards across the main pillars of your use of AWS to go back and remediate things. Maybe someone created an Amazon account, but they forgot to add multi-factor authentication to it, for example. Trusted Advisor will simply tell you these things. And in the same way that we built this simple dashboard on top of the data, you can build your own dashboards on top of the data. We have some great partners out there today, like AlertLogic and others, who give you dashboards across the information being generated from your account. Splunk has a really easy-to-use free download AWS app that will take AWS information and apply rules to it and help you make sense of it. The information's at your fingertips now. We talked earlier on about a lack of visibility. There is certainly more visibility on AWS than I think you could pragmatically achieve on any on-premise environment. We used to design infrastructure. We used to pass them to someone that counted the number of network switches we needed, added all the speeds together, and then you went and bought stuff. And when you changes it, it relied on someone getting in and making changes to the network and other things. Now you can define all of your infrastructure as source code. So we have our code repository, and it has the latest version of our corporate application in it. Stored alongside it is a bit of source code that says this is the entire infrastructure needed to run that application. So we version the infrastructure just like we version our software. And in exactly the same way that when we release code, we went through a pipeline till we got to our production environment, we've done a release process and it updated our running apps, we do the same with our infrastructure. So when we want to change a firewall setting, no one logs into the AWS console and goes and manually changes a setting because, again, that's quite prone to error and hard. You go back and you find the source code for the infrastructure, you update the definitions of the firewalls, and you release that change. We update our infrastructure as we go with changes that came out of a well-defined development process. So we proposed the change, we rigorously tested the change, we stood it up in an integration environment, we did a pen test against it, and only once we were comfortable did someone give the green light to say, apply this to a live environment now. So we have no humans in our operational environment if we can help it. We have no servers with interactive logon because we've built automation that patches things. That we don't need to go and rebuild a server. We keep an image of the server, we patch it, and we just update our live environment with new servers and we destroy the old ones. Because everything now is just software. You don't have to worry about how long a server lives for if you build things properly. And when you've built like that, and when you can run like that, you can just keep going. You can keep going when infrastructure fails, you can keep going during disaster, and you can start to implement resilient solutions that, you know, throw anything at, and they'll just stay up. It allows us to start evolving the entire practice of security architecture. You'll hear the phrase DevOps a lot. Don't be scared. It doesn't mean let your developers free in your operational environment. It means start to build things and think the way that developers think, and it typically just means use automation. It used to be, I was a security architect. I spent 6 months designing an architecture, ticking it off against the policy requirements, negotiating with my application teams because their app didn't really fit the architecture and we had some trade-offs and everything else. Now we can build infrastructure and save the templates for that infrastructure as security patterns. Let's say we have the pattern, corporate micro website. Because in our company, we release a lot of new marketing websites for new credit cards, for new shampoo, for a new phone release or whatever, and we don't want to reinvent the wheel. We have that infrastructure stored as source code. When a developer wants to create a new microsite, they take that pattern, they add their own things to it, and they release it. Automation continually checks the compliance of that pattern against what we had approved. So if anyone tries to deviate from that standard secure pattern that we have, we know very quickly. Either we reverse those changes or we just go and ask someone and say, what were you doing? So suddenly we've baked the security design into everything what we do. We've baked in the concept of getting assurance that the controls are working into everything that we do. And suddenly in our operational environment, the humans become governance. Because the operational environment itself is going to tell us, I am not configured the way that you thought I was. This thing has happened that you may not like, which is very different from the traditional ways of having an ops department where we wrote some handover to ops document and we threw it over the wall and then put our heads down and hope that people knew what to do. We're consistently thinking about how this thing is going to run from the moment that we start writing the source code. So I've walked through a prescriptive approach that you can take if you're new to the AWS cloud, or even you're using the AWS cloud already, but you want to mature your use of it. You can start to follow these techniques and patterns to make sure that you address everything and have your own safe and secure journey. We've got really easy access to security training because it's quite important. We also have paid security training as well, for example, but we've got a journey that you as a security professional can walk through and skill yourself up on this new paradigm and gain the skills that your organization desires in the future. Thank you very much for your time today. I hope you enjoy the rest of the day. I'm available here now downstairs for any questions if anyone wants to come and find me. Thank you.